Over the last few years, enterprises have raced to adopt AI, largely through cloud hosted frontier models accessed by API. That wave proves something critical: intelligence at scale works. But proving it works is not the same as owning it. Today, a new set of questions is emerging at the executive level. Who owns the intelligence? Who controls the execution layer? And what happens when your most strategic decisions depend on models you don't control, data you can't fully contain, and uptime you don't govern? This is not a conversation about tools, it's a conversation about control. Welcome to the Modern Enterprise Unpacked. I'm your host, Wallis Mills. In this episode, we explore what it really means to own the brain and why smaller, sovereign language models are becoming a strategic lever for enterprises that care about resilience, cost control, and long-term differentiation. I'm joined by Victor Paraschiv, co-founder and CTO of Broadn. Victor builds AI for U.S. industrial manufacturing that compresses weeks of technical design review into minutes. At Broadn, Victor leads the effort to deploy AI agents in offline and air-gapped environments. Before Broadn, Victor automated legal contract generation, review, and negotiations. His work follows a consistent theme: encoding expert judgment into scalable systems. As a machine learning scientist and serial technology executive, Victor focuses on capturing how top experts think and making that capability universally accessible through scalable AI. Victor, thank you for joining us on the Modern Enterprise Unpacked.
It's my pleasure. Thank you for having me.
Today, we're talking about owning the brain, the architecture of autonomy. And as we move deeper into what Jensen has referred to as the age of inference, enterprises are realizing that intelligence itself is becoming a strategic asset. Over the last few years, leaders have chased large frontier models through APIs. Victor, what's breaking in that model? And why are organizations now realizing that a smaller model they own can be more valuable than a massive model they rent?
I think you're right. Like the first step in the process was proving that these large language models can actually solve meaningful problems. But once we've established that, we are going through a paradigm shift. I would say like from 2022 till maybe later last year, we've seen this exploratory approach to finding potential problems that are suitable to being solved through AI and large language models. But as we've kind of shown that the LLMs work on a family of problems that are actually very interesting to us, including coding and doing different types of data manipulation and transformations, we are moving into a new phase where we are trying to see how we can deploy LLMs to our specific set of problems. And we've observed that perhaps if the LLM can solve it, the question is like, can we do it better? Can we do it better at scale with lower cost, maybe faster solutions? And in this space, we need to ask a different set of questions. So now that we know the LLMs work, like what can we do to actually scale up our computation pipeline or processes so that we can deploy this in an efficient way? I think we've heard about both failures and successes when it comes to deploying LLMs. And here we have some examples from Klarna early adoption for customer support, or maybe even Salesforce with Agentforce. So by just using AI and the most powerful frontier models alone is not a guaranteed success. And also, we shouldn't forget about the fact that machine learning has been with us for almost a decade and a half. And between 2010 and 2022, the movement didn't really catch on because there are a lot of intricacies when we start to think about how we actually deploy machine learning models at scale. So there's still a few questions that the company needs to answer about, like, what's the risk of my company, which are the most appropriate processes to start deploying models to. But once we start to actually look from first principles at these questions, there are different patterns that the whole organization may surfacing that are ripe for deploying machine learning models and LLMs. And then the second observation is that it's not just about the using frontier models to solve this sort of problems. We know that AI can match human output. But the next question is like, okay, so what shall we do about this? And I think this starts to become the dominant question among early adopters, but also like established incumbents. The key realization is that once the LLM solves it, like there are perhaps open source models that can solve the same problem as well. Sometimes there can be small language models can do the same type of operations in a lot more efficient way. In what we've seen in the last 12 months is that small language models start to become actually useful. We can operate them, we can deploy them in a predictable way into the existing infrastructure. And 20, 30 billion parameter models can do an incredibly good job. Of course, there's a little bit of a gap, but this gap is closing fast. This is a performance gap as well as a like inference speed gap. So as an example, I have the OCR task. We used to believe that we need to run specialized infrastructure to do OCR. Initially, the frontier models used to do a very good job at matching the optimized infrastructure for OCR tasks in terms of performance. But right now, we start to see a lot of very small models, 4 billion parameters, right? Sometimes even smaller, that are able to achieve state-of-the-art results at a fraction of the cost of the LLMs. So specialized tasks can be easily delegated to open source model and smaller models. This is an interesting opportunity because we can cut down the cost and the speed. And once companies start to look at integrating AI into their system, there's another interesting pattern that emerges. You actually don't need to use everything on AI. I mean, of course you can, but to achieve operational efficiencies and keep the cost in checks and have a reliable process, the pragmatic approach begs to weave deterministic execution with AI agentic systems or LLM calls. In this blend of computation, you can get a lot of incredible advantages along the lines of reliability, consistent output, speed, cost, and even precision.
Victor, what I love about that framing is that frontier models weren't the end state, they were the proving ground. And now the frontier is actually just widening. So, who would you say tends to recognize the shift first inside of organizations? The CIO, the CTO, the CFO, or is it the business leaders who are closest to the operations? What are you seeing?
I think the leadership structure of each company is very different. And it's the question about the opportunity as well as the risk. If the opportunity and the risk sit within the same function, that I think those individuals, be it CIO or CTO, are the fastest to recognize the opportunity. And then the fact it begs for a new approach where everything is integrated. If the companies manage to have the same like responsibility that lives in the same function with the opportunity, then I think that's great. And this is already a setup that's prone for success. However, in older companies where you treat risk as a different function from actually achieving operational efficiency or maybe tackling different opportunities, this may be harder to recognize that we need to think about AI in a different way.
Agreed. So, as we think differently about AI, when we talk about sovereign AI through smaller language models, are we really just talking about privacy, or is there a deeper strategic shift toward enterprises owning their internal intelligence? And how does that change infrastructure strategy compared to relying on cloud hosted AI?
It's a very good question. And when it comes to like sovereignty and intelligence sovereignty, especially, I'm not necessarily thinking about small language models. This is just a simple tool. But again, with this new paradigm that's emerging, the way I think about intelligence sovereignty is in two separate pillars. The first one is having the ability to execute calls to different language models or image models in a way that is entirely decoupled from the uptime of the frontier models and also the cloud providers. In the last year alone, we've seen a lot of outages, and we start to see how the models start to get at maximum capacity at different moments of the day or of the week. And if your organization is entirely relying on the cloud providers to execute these models, and let's say you actually work in some critical infrastructure like defense or maybe manufacturing or financial services, you cannot have this execution operating mode strongly coupled with individual frontier model providers or even cloud providers. So you need to start thinking about how you can actually achieve decoupled execution of large language models or small language models in a way that doesn't necessarily force you to have an uptime in alignment with the rest of the cloud. And then the second thing when it comes to intelligence is how you deploy it. Do you have a way to steer these AI models to do novel, cool things? And ideally, this novel thing should only happen within the boundaries of your own organization. Security is paramount, and we start to see how important it is to be able to contain the data and the proprietary data sets that your organization has the ability to create. We know that the public data for LLM training is becoming scarce, and we start to hit some barriers here and some limitations in terms of what can be squeezed out of the public data. Frontier labs are starting to strike commercial deals to collect proprietary data sets that exhibit different features and layers of intelligence that might be interesting in being integrated. We start to see how distillation of the large language models, frontier labs, can happen by the smaller research labs, maybe Chinese, through VPNs and different tactics. So again, data can immediately leak into the public space, and once it's in the public space, the cat is out of the bag. You never know how long it's going to take up until that particular trade that you have in your proprietary data is going to be observed in the language models. The execution layer, I think, is things are getting very interesting because serious businesses, again, don't want to have an uptime that's strongly coupled with the cloud. They need to start to think of a meaningful way to actually continue to execute in air-gapped or maybe offline environments in your own data center, on your own premises. Large enterprises, of course, they're very well positioned to get provision throughput in private cloud environments. But at the present time, I feel like the market is still emerging different patterns in which this independent execution layer can happen.
I appreciate how you help us to appreciate that there's many ways to think about mitigating risk. Often enterprises are working, 5, 6, 10 years out. But if what you're doing today in an effort toward, a decade from now is already leaked, well, that can put companies in a really interesting position.
Correct. And if we think about like how the last decade and a half went, this thought is already in the public forum where many companies were told like your proprietary data is gold. You should hoard it. You should treat it as a first-class citizen within the tools your enterprise has to deploy intelligence. Yet the machine learning models, the previous class of machine learning models kind of failed to deliver on this promise. But right now, we are finally finding ourselves in a space where through fine-tuning and training these small language models on our proprietary data set, we can actually achieve that kind of level of novelty and deploying models that are quite unique to the way each individual enterprise operates.
Okay, so we've talked about risk, but cost pressure is also just as real. And you've argued we're moving from GPU scarcity to efficiency, and I totally agree. So how does sovereign small language model deployment actually help enterprises escape unpredictable API and cloud OpEx?
Well, it's a very interesting question and a very important one. And it definitely relates to the process through which we are moving a product that's been proven to be working great on frontier LLM capabilities into making that part of our operational infrastructure. And there are a few tenets here. The first one is when an LLM works, it means like we have already the right ingredients to be able to solve that problem in a more structured and methodological process. When we are decoupling away from LLMs, we need to firstly kind of come up with an infrastructure where the models are fungible. They are interchangeable. We can replace one model With other, we don't necessarily have to rely on one specific model to solve one specific class of problem. Perhaps that would be viable for the first iterations, but at the end of the process, we need to end up with functions that can be delegated to different models. The models can be executed in a cloud provider, can be executed on edge devices, can be a small language model. And this iterative process where we are taking a very complex process and we start to break it down into its constituent parts, we start to identify what is the deterministic execution, which particular functions can be delegated to a language model is incredibly valuable. Because if you break down a very complex function that's today executed on a frontier LLM into smaller bits, then those smaller bits, provided they're less complex, can be delegated to open source model, small language models, and we don't necessarily care exactly what is the model that allows us to execute. This decoupling is incredibly important when we start to think about our sovereignty, because we don't want to have this, again, strong ties with certain models. Then the second thing when it comes to cost is, of course, even when you look at the pricing landscape, some models can be up to 150 times, 150% more expensive than other models. And actually what you get for that, you don't get the same uplift in terms of performance. You get the marginal performance increase when it comes to solving generic problems. If you manage to break down your operation pipeline into very well-precise functions, then you don't need to always pay this cost. Now, of course, the cost of frontier models is expected to decrease, but if you manage to do the hard work of completely understanding the methodology of your process, to break it down into which bits can be executed deterministically, which one actually need to be delegated to a language model, you start to see that the cost profile for your entire AI pipeline and agentic approach can be much smaller and is not strongly coupled with the pricing of Anthropic or say OpenAI or other model providers.
You've mentioned, and I like the term decoupled model, because I think sometimes when people think small language models, they're thinking too much about size, and we're talking about them relative to frontier models. And I also appreciate that as you talk about OpEx and a way to approach this, it's not really a either or type situation. It's not you're here or you're there. And I think a lot of the incredibly large enterprises have had to think about that from the beginning. I think about like Amazon and AWS or Walmart that have to deploy from, they're going from one end all the way to the edge. But this is a moment for every enterprise to say, wow, we can be way more strategic. A quick pause here, because what Victor is describing isn't just an infrastructure decision, it's a leadership decision. The shift towards sovereign intelligence forces enterprises to rethink how data, models, execution, and governance actually fit together, not as isolated initiatives, but as a system. At Modern Enterprise, this is exactly the work we focus on, helping leadership teams translate deep technical change into durable strategy before cost, risk, or complexity forces a decision for them. Learn more at modernenterprise.ai. And now, let's get back to the conversation. So let's talk about the dark side of connectivity. You've raised a fascinating and frankly concerning concept about agentic collusion. And that's the idea of independent AI agents collaborating in ways that totally bypass human oversight. Why is architectural containment or owning the brain the only real defense against this kind of autonomous drift? What does real autonomy look like in practice?
I think this is a very important question. And especially with what we've seen the last weeks with mold books and AI agents able to collaborate and an increasing emerging of different agent-to-agent communication protocols where we expect agents to be able to negotiate with other agents different business terms are emerging. This is a very important question and it cannot be left to be solved along the way. This needs to be a tenant in the strategic approach an organization takes to deploying machine learning and AI models at scale within the organization. And also, like, I think this also ties to some investors and how founders think today about where the value of a company is, what makes a company unique, what is the moat. And the answer are still coming from different perspectives, but still seems to be like it has to be a data play where you cannot have a company that becomes successful in the marketplace and thrives over multiple years that has a leaky data bucket where this data it's leaving the organization and the organization cannot contain it. And I would even say like right now is probably for the first time in maybe 20 years where we can actually act upon the proprietary data that our company is accumulating inside using with the technology stack that we've seen, and we can act on these data very fast. And containment is not just about necessarily having nefarious activity between agents, but making sure the agents are not leaking proprietary data, making sure the agents that you've deployed within your organization are enriching and creating novel data points that later on can be leveraged within your own premises to create novel functions that nobody else can do. And I think there will be a family of companies that will be incredibly successful deploying their strategic view in that includes AI in a way that will allow them to create novel functions. They'll be able to create value in a way that no other company can. And maybe we have a few examples right now if you close our eyes today, like maybe Amazon or Google, but I expect to be a lot more companies doing so. And this will have to be related to the way we generate data, the way we collect data, and how fast we can integrate the novel data points we are generating on the back of the process, being explicit data collection, implicit signals that we are accumulating. We deploy this into trained models that are only available within the premises of our organization.
I think we are completely aligned and that it just makes sense to own your intelligence. If I wanted to do that, what would I need to actually control architecturally to pull that off? Like, what does that look like? Is it the models? Is it the data? Is it deployment? Is it orchestration? Like, what does it mean to actually own intelligence?
I believe it's all of the above. I believe like the data is incredibly important. The latest jumps in LLMs are more about data curation and quality and domain representation than volume alone. The data volume needs to be scaled properly with the model parameters, but of course, we need to curate and we need to accumulate data within the premises of our organization that is produced perhaps by the simple operational business processes that are currently running. We need to generate implicit and explicit annotation to these data points. And companies need to make sure the appropriate data retention policies for each critical process creates new data points, transformation, and decisions. Event logs are incredibly important. We need to be able to trace processes and find the source point of each individual data point. We need to have single points of truth within our organizations. It used to be for a long time incredibly hard to break the data silos. Now that job still needs to be done. And in addition to this, we need to also look at the bigger picture on how we are deploying intelligence and looking at this organizational brain, as you call it. I think the second pillar should be the execution. We've discussed earlier about this decoupling that needs to happen between the cloud providers and specific models and how we execute our AI pipeline. We need to have this ability to change or replace models, and this is going to give us independence when it comes to executing the models on premise, on our own GPUs, or perhaps using the cloud. And finally, training. So we are operating a business that generates proprietary data sets. We have a way to deploy machine learning models, AI models, LLMs, either in cloud or on our own premises. We can operate small language models that can still achieve the same performance as the cloud functions, But right now, we need to start to deploy and mix the two. We need to take our own proprietary data set and be able to use it for fine-tuning and pre-training our own models that would later on will allow us to tap into new capabilities, new functions, and new outputs that will be unique to our business. So I think we need right now to tackle the three of them at the same time.
So it sounds like data becomes everything. And so just to kind of like double click on that, and I know you just said a lot about data, but how can enterprises rethink how they're curating and structuring their data for smaller language models?
Well, this is a point that was discussed, but perhaps it was only theoretical because we didn't have the means to execute on utilizing proprietary data and deploying in machine learning models. Traditionally, before LLMs, this used to be a process that was perceived to be incredibly expensive, and very few companies actually have seen the results of that good work. However, right now, private data sets are gold. We start to see frontier models trying to cut special commercial deals to be able to access domain specialized data sets. Cleaning data is incredibly important. And we need to consider data as one of the key ingredients for an organization to succeed. So, for example, when we think about the legal sphere, the contracts that are available today in the public domain, they only cover a very limited set of contractual obligations and terms. Perhaps NDAs are very well represented, but we have very little representation when it comes to commercial agreements, derivative contracts, and more specialized commercial agreements that cover different instruments to deploy on certain deals to be able to ensure certain outcomes. This data today finally has the opportunity to be integrated into fine-tuned proprietary models. How do we do this? We need to have the right policies, we need to have the right technology stack, and also the team that thinks strategically in terms of advantages and what is possible. If a frontier LLM model can do it, we can probably consider it as acceptable that we can replicate similar capabilities on our proprietary data set that only works for our company.
The legal component is something that I hadn't really thought about in terms of how that needs to expand, and that is something for our audience to think about. But let's go all the way out to the edge, right? So we're seeing intelligence move from centralized clouds to the point of work, right? Factories and stores, devices, and private servers. What are the biggest technical hurdles enterprises face in moving intelligence to the edge?
I think there are two patterns that I've seen within the organization. And perhaps even before the technical challenge appears, and it's definitely meaningful and it's an important challenge, and you need to have the right technical skills within the organization. I think there's more of an executive team challenge because you need the full organization to support this strategic direction where you're deploying intelligence within the premises of your own organization. And the decision to move to the edge is actually incredibly important, which means you need to have a total commitment of the executive team and the leadership to follow up on that commitment. This cannot be a lone effort, and this probably will not succeed, as we've seen in so many examples up until now. So there needs to be an entire strategic alignment within the organization that this is the path, and this happens for the right reasons. Now, on the technical front, you definitely have to have a very good team. You need to have a good map of the business processes. These processes need to be well understood at the finer granular level, how they operate. And lastly, you definitely need to understand the landscape of the data silos within your organization. You need to understand where's the data originating from, what data points are created as new throughout the business processes, and what exactly is the final outcome that you're selling to your customers. Once you have a clear understanding of all these three pillars, it's only then where you start to decide exactly how much of this complexity can be delegated to the edge compute. Edge is generally a very important discussion point when you think about critical infrastructure. This may be in manufacturing, as some of the activities we've done for some of our clients are shown. You can start to see in financial services, insurance, banking, where you definitely need to have some sort of capability to execute when the cloud is down, or perhaps for different other business reasons, you cannot delegate to a cloud inference stack your computation.
Okay, so we've talked about a lot of this strategically, which I appreciate as a strategist. I'm really appreciating this conversation. But let's talk about hardware. GPU scarcity and VRAM costs have sidelined much of the mid-market. Do smaller language models running on local NPUs or non-CUDA hardware actually level the playing field, or are we just changing what we're asking the hardware to do?
We are definitely changing what we've been traditionally asking the hardware to do. There is an increase in how hardware is able to cope with transformer models and with small language models. Over the last year, we start to see hardware that is doing a better and better job at accelerating the computation, and we start to see reasonable performance when we start to look at these edge devices. And I think like over the next 6 to 12 months, we'll start to see a lot of adoption of these edge devices, but also increased performance. CS 2026 shown like the future is on the edge. And I mean, even today, there are solutions where you can speed up edge computation to acceptable levels that are working at an organization that perhaps has 200 employees. So I've seen companies deploying even, let's say, retail or consumer grade accelerators, the NVIDIA accelerators that can cope with the CUDA cores. Here we can talk about the 4050 series. There is NVIDIA Pro GPUs, the A4000 and 40S, that can already take you to 300 tokens per second. You can do further optimization by introducing batch processing when you have a lot of requests. AMD starting to do a good job with their Instinct series. Again, we start to move towards 500 token per second. The Grok chip, it's a next leap forward where you can hit close to 1,000 token per second. There is a bit of a hard cost, close to maybe $20,000. But when you start to look at manufacturing and industrial environments, there are sufficient compute platforms that are also allowing you to operate small language models at scale. Here, Qualcomm with Snapdragon and Dragon Wings are already like leading the innovation front, where you can achieve, again, like 100 of token per second for small language models that can be deployed in heavy industrial environments. AMD, the Xilinx platform, again, is pretty good. So I would say like for a cost that's probably less than what it would cost a regular company to implement an ERP or CRM module, you can get the computational stack that allows you to be efficient on-premise in an even like air-gapped environment. We're going to see incredible improvements in terms of capacity and generation speed.
If you're listening, Victor just gave us an incredible breakdown of the hardware landscape. If you're trying to keep track of those specs, from the NVIDIA Pro GPUs to the Snapdragon chips, don't worry. We've documented the full Hardware for Sovereignty list in a companion article by the same name as this podcast, available on the Modern Enterprise Unpacked column on Substack or on modernenterprise.ai. Okay, now back to our conversation. I know you talked a lot about like having the entire executive team or leadership on board to support a lot of these initiatives or make a lot of these things possible. You also talked earlier about how, kind of like compliance and risk has been handled and operationalized separately in some of the larger, older organizations. So as intelligence becomes embedded in operations, governance shifts from a compliance reporting to an operational type control. So what does real autonomy look like in practice? What does this new landscape look like?
This is a very important problem and a very important question, because compliance generally used to live outside the loop. And just because the business processes operated on a very slower pace, compliance used to be some sort of out of loop process that every quarter is assessing some of the KPIs of the business. Now, in the new paradigm, compliance cannot live outside the model anymore. It needs to be incorporated in the business process loop and needs to have access to real-time data. AI speeds everything up by multiple orders of magnitude. If a manufacturer could take 2 weeks to respond to a request for quote last year, this is definitely not the expectations in 2026, where customers expect 2 minutes and maximum 24 hours. And suddenly, all this data speed up is going to affect all the reporting, the governance, and the compliance functions. This needs to be an integral part of the data flows, and it definitely needs to see the data in real time to be able to have strategic controls over steering the processes without necessarily developer interventions. So the AI models also need to be, and the process needs to be steerable, and we need to have the right knobs and controls in place so that the KPIs are not just something that is observed, but also something that is within the capabilities of the organization to control for. This is why I mentioned earlier that adopting this wave of AI requires the full organization to buy into this shift. Simply offline processes have nowhere to hide. The whole organization needs to be wired to a live stream of data.
You talked about knobs and controls, so let's go there, right? So enterprises move on, and they decide that they're going to go from just having one general model to fleets of specialized models. You know, they took this moment to think, they've strategized, they've decided that's what's best for them. How are these systems going to be orchestrated and governed?
Well, this is an important question, and answers are still emerging from different technology approaches. But I think there are some patterns that are actually quite clear. We've touched earlier about the importance of decoupling from the model and cloud provider execution. When this decoupling is complete, the infrastructure will end up treating models as fungible functions, completely replaceable models and interchangeably swappable without any loss of functionality. Of course, there needs to be some work done here where, again, like each individual operation is broken down into its constituent parts and delegated to models that can execute it appropriately. This also enables a strong execution platform that can retry requests, can route calls to multiple models depending on the availability and the functionality required. When you do this upfront work to demystify and unbundle frontier models into smaller operation, you start to observe like a variety of small language models, and perhaps even deterministic execution is suitable for you. When these two requirements are met, like you start to see that your organization is able to orchestrate and control this model a lot better. So instead of relying on the magic of the LLMs, you actually know that everything is within your control to change and adjust.
I like that. Okay, let's talk about magic, because that's a huge concern with AI. It's a black box problem, like what is really happening. And so you talked about this new ability to have a different level of observability. So how does owning the model and the infrastructure change auditability and the human in the loop governance? Like, how does this create more transparency and the ability for explainability?
Well, this certainly is a paradigm shift again, because we used to believe that if we have processes where the humans are performing the work and we ensure that the correct policies are set in place, and we kind of said like what's the standard of a business process with certain KPIs, that process is always going to produce good work, and that is sufficient because we have a transparent view over the end-to-end process. But we've seen directly this is not quite working well. We've seen this in healthcare, we've seen this in insurance, awarding grants, loans, or even sell processes. And we even start to correct for some of these misgivings of the current human-driven approach by introducing 360 feedback loops complaint lines. You can call support. We start to introduce NPN scores just to determine exactly what's going wrong in our attempt to fix the poor services. And this kind of works to some extent and introduces an onerous process in certain parts of the organization. Now, what's changing with the AI? With the AI, the LLM execution, we need to think in terms of processes. And here this is my own personal opinion, but like the how doesn't matter that much. It's more about the requirements. It's more about observing the input-output pairs of data points. We need to start logging data, the input of the system, and also the output of the system, and starting to describe the entire process in terms of outcome. What is that we expect the process to produce? And how does it look like when the process fails? When operations need to improve, AI models are easier to retain and deploy than upskilling your entire teams. This means like if we start to look at the systemic characteristics that we are set to achieve, we can put a lot more controls and we can measure a lot more and a lot easier the data points that flow through our system that it previously used to be with a human-centric approach.
Let's think about process, and I like that you leaned into process, and I agree with your opinion, and I think this is going to be different maybe for everyone. We're kind of stepping into a space where this new sovereign workspace and employee workflows could be completely automated, and perhaps intelligence and data never leave the organization. We're creating this incredible new level of automation, and we're keeping that data private. We've talked about all the goodness that delivers. I think when people think about even LLMs, SLMs, it doesn't matter. The first thing that comes to mind is a chatbot, right? But I love the fact that you use the word process. So can you help us to imagine what this looks like? Is it an invisible layer that lives in the? Is it apps? Is it what does this look like?
Well, the chatbot probably was an ad hoc way to kind of design a process where you prove to yourself that when I'm starting from this input and I ask a series of questions and the LLM or the chat interface is performing either knowledge retrieval or actual transformation functions over the input that's been provided or acquired through different queries, we can actually get to the end result. So what we're doing in a chatbot when we think from an abstract perspective is that we are creating an ad hoc business process that proves that given this input, I can produce the expected result. Now, when we start to see how this would actually scale at the level of a sovereign workspace or an organization, these ad hoc processes somehow need to be collapsed into something that's a bit more generic. Historically, we used to have people that operate at each individual data point. Let's say in a sales process, we're looking at the incoming request from a potential lead or customer. We need to perform different transformation, which the human operator probably find it pretty easy. Some copy-paste operation to an Excel spreadsheet or running to the quote configuration, producing an order, sending an invoice, customizing the product. So that entirely is a process where people were interjecting at each individual step in the process to correct the data, to generate the data, to structure the data. Now, when we are introducing AI, what happens is that some of these individual interjections can be automated, more or less, probably on the more side. And right now, the people need to think, the humans, the operators need to think in terms of systemic changes and systemic processes where we are observing thousands of operations per week, and the job is not to look at individual data point, but to think about the outcome. What's the input? What is the correct output? Did we get any errors? What's the SLA? What's the performance of this individual business process? And then provided we are able to collect the data points, we can close the loop by perhaps training a small language model on our proprietary data set that we've been collecting over the last week, train it in 3-4 hours, and then deploy it at the end of the business day. which means that we have this loop that somehow strategically is still corrected and adjusted by human operators, given different other set of business objectives. But we are changing where the human operators are interjecting in the full stack of operation and decision. Instead of looking at individual data point and data operation, we start to look at systemic processes and how they're all connected at the organization level to create intelligence and to generate novel functions and outputs.
That's a huge paradigm shift, I think, for people to think about when they consider sovereign workspaces, but especially when I think about small language models, because I do think those chatbots are the first thing that come to mind, and this is so much bigger than that. And so I love that, systemic processes. Speaking of paradigm shifts, let's talk about misconceptions. So what is the biggest misconception enterprises currently have about deploying smaller language models?
I think they're very scared of small language models. And I think the first myth that's needed to be bust is the fact that you always need to deploy the latest frontier large language models to solve the AI problem. And there's this level of prestige. Oh, my business is so complex that I need to deploy the latest Anthropic model to solve my business problems. When in reality, if you do the hard work of, again, like demystifying what the LLM is doing, you realize actually your process is made of some very simple steps linked in a sequence, or perhaps like they operate in a certain way, but those individual functions can be easily delegated to a small language model. So an interesting small language models that are definitely worth investigating is the Nematron model, which has a huge context window, very close to, it's 1 million tokens. It's similar to the latest Gemini model, even larger than the Anthropic models. That is actually incredibly capable of doing a lot of the work that you think like maybe just OpenAI can do, or you need actually the latest Anthropic model to do, like data classification, routing, extracting structured data points from unstructured natural language. And SLMs, I'm very sure like this is not necessarily a prediction because it's already happening, but SLMs are doing an incredible job at smaller scale with a faster execution inference speed that it's hard to imagine. But when you try to take your existing process to an SLM, you realize that perhaps 90% without any adjustment can be operated today.
That is incredible to think about the fact that people may be overdoing it and they be making things more cumbersome than they need to be. And actually, they could be far more efficient with the smaller language models. There's a real opportunity there. If a company is fully dependent on frontier models today and they want to capitalize on this goodness, what is the first move they need to make towards sovereignty for tomorrow?
Well, I think it's already great news when a company tries to adopt frontier models and they've proven it works. Because when it works, it means like, okay, now we understand where the data is coming from. We understand what the process is. We have a team in place that can manipulate data, give it to these models, and understands what like the single point of truth within our organization is. We've already mapped the entire process and we understand the requirements. This is a lot of hard work that's not necessarily immediately actionable, but that needs to be done anyway. And since all this work is done, I think an organization will be ready to start to look into smaller models. And well, this is a progressive effort. You need to iterate to take some of those large functions that are today performed by the mystical large language model, and you try to give these functions to open source models and to see to what extent the results are matching the expectation. Most of the time, the observation is going to be that actually smaller parameter models can actually do a very good job. If you want an SLM to execute the job, perhaps you need to break that particular individual process step into smaller steps, and immediately SLMs will become very good at executing those jobs. The frontier model today are superior at executing 3-4 steps into a single call, where you put everything you need or everything you think you need in a very large context, and magically the LLMs are getting the job done. By being a bit more intentional with the data, the context, and the order of the operations, you start to see that a lot of the big processes can be delegated to small language models.
It's funny because it kind of brings us to the beginning of our conversation where we talked about the fact that frontier models have been kind of almost a proving ground for a lot of things, and they can still be that for the enterprise today. And as you mentioned, a really great opportunity for them to observe the parts of their processes that can be moved over to smaller language models. If we were to reconvene in 18 months, what will enterprises that moved early towards sovereign intelligence have that others won't?
Oh, this is such a very, very good question. I think the movement towards sovereign intelligence will reveal and will map out the unique data opportunities within each organization. This means that they will be able to act on deploying proprietary models that were trained on their very specific and unique data sets, which is going to lead to better unit economics, better business outcomes, also speed when it comes to actually executing operations on your proprietary models. And then, not lastly, diversify your portfolio of products and services that you're offering to your end customers, because suddenly they will be going in depth in terms of your business capabilities, because simply you're just leveraging your own proprietary data and you understand it.
This has been a masterclass, Victor. Thank you for helping us to map the architecture of autonomy.
It's been a pleasure. Thank you for having me.
As we wrap, I want to leave everyone with one idea. The enterprises that move early towards sovereign intelligence aren't just optimizing cost or improving uptime. They're learning how their organization actually thinks. They're discovering where their proprietary data creates real leverage, and they're building execution layers that can adapt as models, hardware, and economics inevitably change. Frontier models showed us what was possible. Sovereign architectures will determine who can sustain it. If this conversation sparked new questions for you, we'll be unpacking several of Victor's points in the companion article by the same name. I'm Wallis Mills, and thanks for spending this time with us on the Modern Enterprise Unpacked, where we help leaders understand when, where, and how to hedge their bets in the era of AI. Until next time.